In this practice problem, we want to find out is there a relationship between gender and having allergies. And so we use a random number sampler at the Census at School website, and we pick 40 high school students to complete the survey. Here's a two-way table showing all this information. So are the events female and allergies independent? That's the first question. So the way to figure this out is we say, what is the probability of having allergies? Well, that's not spelled right. Allergies. Given that you're a female. And is that equal to, then, the probability of just having the allergies? That's the question. So we check out the first probability, allergies and female, or given that you're female. So the intersection of the allergies and the female is a total of 10. And then out of the total possibilities of being female, which is 23, and we ask ourselves, is that equal to the probability of having allergies? So the total allergies was 18 out of the 40. And we notice for sure that these two things are not equal, so then the answer is no. They are not independent. Wait a minute.
Wait, we're just doing female stuff.
Right.
So it is because it's 10 divided by 23 then. 23. So then
No. Second, we're supposed to choose 2 students at random and draw a tree diagram that shows the sample space for this process. So if we draw a tree diagram, we have the students that we're choosing from, and we could choose the allergies and not allergies, right?
Male or female?
So we got the allergies, and the allergies were the 18 out of the 40. And the non-allergies were the 22 out of 40. And then, if we pick the first student, that's what our chances are. The second student, this is for the first one. And then we do this again for the second student. And because these are not independent, like you're not replacing the student, now you have a different student that you're choosing, right? So instead of being 18 out of 40 for the chance of having allergies, it would be, no, 17 out of 39. So 17 out of 39, which means there is a 22 out of 39 chance that they wouldn't have it. And this is the second student. Well, it's 39.
What's 17 plus 22? 30.
Oh, yeah.
Yay. Okay, next.
Okay.
No,
Whatever.
I'm confused.
All right. Thanks. Okay, well, let's talk about it in a second. So down here, 22 out of 40 would be the first student. And then left over for not having the allergies.
Are you asking a question?
Yeah.
21 out of 39?
What? 21 out of 39 is not. And for yes would be 18. So yeses and nos based on the total. So this person you selected out of the 18 that had the allergies is already gone. There's only 17 people left over. The 40 people, one of them you already chose. That person's over here. They're gone. So there's only 39 left over. Does that help? Yeah. Down below, same thing. If you already picked the person that didn't have allergies, that means there were 21 people left over. And they had a total up to 39. if I look at the probabilities for each of these cases, when I multiply the probabilities, the first one turns out to be 0.1962. The second one is 0.2538. The third one is 0.2538. And the last one is 0.2962. So these were the allergies, not allergies, allergies, not allergies, allergies, and not allergies. So down below we're going to ask a couple questions based on that tree diagram. So the first one says, find the probability that both students have allergies. As I look at my tree diagram, if I want both to have allergies, I follow the A's along. So that's the first tree branching up to the top, again up to the top, and I go across. And the likelihood that they both have allergies is 0.1962. So I write that down. The probability that both first and second have allergies equals 0.1962. That came from right here. And then the second question says, what's the probability that neither has allergies? And so I follow the other branch, or one of the other branches. So neither student has allergies. And if I follow the bottom branch, no and no, that's 0.2962. So this computer company is making desktops and laptops in 3 states, California, Texas, and New York. California produces 40% of the computers, Texas 25%, and 35% are in New York. 75% of the California ones are laptops. Texas has 70% laptops, and New York has 50% laptops. And we want to ship them to a distribution center in Missouri before being sent out to stores. Let's look and make a tree diagram. So I've got all my computers. And there are 3 possibilities. Possibility number 1 is 40% from California. Possibility number 2 is 25% from Texas. And possibility number 3 is 35% from New York. After we do that, we look at what's happening with laptop versus desktop. So in California, we had 75% of those being laptops and 25% being desktops. In Texas, we had 70% being laptops and 30% being desktops. And in New York, we had half and half, 50% laptop and 50% desktop. And if we look at what this means, for each of them, I get 0.3 for the probability, 0.1, 0.175, 0.075, 0.175, and 0.175. So question B, what's the probability that we have a laptop? We just add up all the probabilities, so 0.3 plus 0.175 plus 0.175 for a grand total of 0.65. That's the probability they didn't ask for a percentage. And then the next question was, what's the conditional probability that it came from Texas, given you know it's a laptop, so that's the probability that we're from Texas, given it's a laptop. So we want the probability of Texas and a laptop, which turns out to be 0.175 from the tree diagram. given that we know it's going to be a laptop, which we just found, which is 0.65, for a percentage of 0.2692, or a probability, excuse me. And then the last one, they ask for the conditional probability that it came from New York, given that you know that it's a desktop. So first one is it's from New York, and then the second is that you know it's a desktop. So New York and desktop, if we look at that, is 0.175. And if we knew that the laptops was 0.65, that means that the desktops have to be 0.35, because it's the remainder of the computers. And when you divide those two, you get a 0.5 probability. Questions?